Okay guys, so today's lesson will be on matrix multiplication in C++. The algorithm we will develop is quite handy because it's very universal, very versatile, and it uses the native data types which are built in C++, okay, in the standard template library. But firstly, before we start to develop something in C++, I'll just briefly review the basic properties of matrix multiplication. I'll use Microsoft Excel, okay? So here we have two matrices. The matrix A is of the type 3 times 3 because it has three rows, which is the first number, and 3 columns, which is the second number. Okay. Similarly, for the matrix B, it is of the type 3 times 2. So now you really see that this corresponds to number 3, and there are only 2 columns, which is the second number. Okay. And if we multiply by matrix A the matrix B, which is A times B, you get a matrix like this, so matrix C. Oh no, just like that, and it will have this dimension. Okay, I'll explain very shortly, but let's first see what Excel calculates. So you use the function mmult, matrix multiplication. You take the first array or the first matrix, the second, and now you hit CTRL Shift Enter. Okay, and you got the product of the two matrices. Notice that it is important if you multiply matrix B by matrix A from the left, or if you choose some kind of different combinations. Okay. Well, the important is what's the dimension of matrix C. Okay. The dimension of matrix C is the first number of matrix A, which corresponds to number of rows in the matrix A, times number of columns of matrix B. So we can see that matrix C is also 3 times 2. Okay, this 3 goes from here. 2 apparently comes from matrix B. Okay, and there's one more important property, and it says that the number of columns, which is 3 in the matrix A, must be the same as number of rows in matrix B. So this number must be equal to this number. Okay, otherwise you cannot multiply the matrices. Okay, so we have reviewed some basics of matrix multiplication. I'll just show you how to get the number in here. Basically, if you want to get the first element, you go like this. You take the element from A, you multiply it by B, and then you take this one, multiply by the second. Now we'll take the third, multiply it by the third in matrix B, and now you get the number minus 11. Okay, if you want to get this 72, it's the same. You use still this row, but you multiply by this row, you multiply this column. Okay, so you take 1 times 3 plus 5 times 4. You always multiply the same the same elements, like this one is second, so this one is also the second. Now you take the third one, and from here you also take the third one, okay, and you get 72. And likewise you could complete it. Now you would just use the second row, and you start here with the first column, okay, and in this way you get this whole matrix, which is the product of A and B. Okay, and now we are going to, rewrite or to create some kind of algorithm that computes the matrix multiplication in C++. I know that it's quite a big issue because there are many people asking on various forums for help, and they really get rather bad suggestions how to do it. Okay, so here we have a new C++ project. Okay, I have 3 files in it: the head, which is the header, the body, which will contain the main functions, and some like main file called main, which will just create some instance of the class we will have in head, and so on. Okay, so let's start with head. Here we typically type pragma once to avoid like multiple instantiation, and here we create class matrix operations like this. In the area public, we will have some code later, but it's not that important right now. And in the body file, we also want to have pragma once, and you want to include head.h, okay, and in here you also want to have head.h, and since it is the main file, the core file, you have to put in here void main, just like this. This is the typical way you start some application in C++. Okay, well, what are we going to do now is we want to create a method that will produce a matrix. Before we can perform matrix multiplication, we must create say own data type, something like own data type, but in fact it is not our own data type, it's inbuilt, but we really need some special thing like a matrix. Okay, so what I usually do, I use the vector. Okay, so I'll put here include vector, and now we want to create the matrix, or the function that returns matrix based on the dimension we want the matrix to have. Okay, so what could be the matrix? Usually I define matrix as a vector which holds vectors. I know it sounds weird, but see this vector of vectors, and this vector has double in it. Okay, don't forget to put using namespace std, so that we can use the shorthand vector instead of std something and so on. And it will this will be the output of method called define matrix, and the inputs will be integer dimension m, or just dim m, and integer dimension n. Okay. This stands for the number of rows we want the matrix to have. This stands for the number of columns we want the matrix to have. Okay. So now we go to the body file, and we can actually copy this thing here, and since it is a member function, we have to use matrix operation, just like that. This is all perfect, and now we want to create the vector, the first vector. Okay, so we create vector of vectors of double called matrix. Okay, and we want matrix resize to dimension m. So at this moment we have a vector of dimension m, and for every vector, for every element of this vector, we create another vector. Okay, so we set for and I equal to 0, I is less than dimension n, do I plus plus, and as I said, we do the following: matrix I resize to dimension n. Sorry, here shall be m, because in this moment, at this moment, we have really a column vector, and we loop through every element, and from every element we create another vector of dimension n. So at this moment, when this loop ends, we have really a matrix. Okay, and we will return that matrix. Okay, we are sure that this matrix has this data type, which is declared here, and it is also declared here. Just put this away. Here we also want to include, and we that's I think that's fine. Maybe it's not necessary to put it in here, but I don't really care. Okay, so we will just instantiate an instance of that class. So matrix operations mo define matrix, and let's test it. Let's say matrix 3 times 3. Okay, and we will call it I'll just misuse this data type, matrix test. Let's see what happens. I'm afraid that there will be some kind of mistake in my code. It's always like that, but we'll try. Okay, so there are 7 errors. I always forget to put the semicolon in here. Oh, not in here. In here. Oh, now it's working. Okay, so let's just go inside and see what happens. So now we can see that we have really a vector that has three elements 0, 1 and 2. Don't forget that the base number for vector is 0. Okay, so if you have a vector of dimension 3, it starts by 0 and ends by 2. Okay, and for every element, for instance, we start with this one, it creates a vector. Okay, so I hope you can see it. Okay, so at 0 there are three numbers that can fit into the 0 column, 0 row. Likewise, we will step forward. So for the row denoted by 1, which is actually the second row, you get another complete row, and the last one, and thus we have a matrix. Okay, so this is a matrix. This is really a matrix. It is 3 times 3. Okay, 3 columns, 3 rows. Okay, so this is working just fine, and we'll now create 2 matrices. Okay, just to test the algorithm later, the matrix multiplication, because now we have just finished like creating a matrix or the matrix space. Let's have matrix 1, which will be 3 times 3, and let's have matrix 2, which will be 3 times 2. Okay, those matrices are empty now. We will later put some numbers into this matrix so that we can see how the matrix multiplication works, but before that we must create the algorithm for the matrix multiplication. Okay, now we have the definition of matrix, but now we will now step forward to create the algorithm for the multiplication. Okay, so here I'll put a function called mmult, which is actually the same as in Excel, and it will return matrix, which is the product of 2 matrices. Okay, and so the function will be called mmult, and the inputs will be matrix 1, matrix 2. Okay, I'll take this definition, put it in here, and define the scope. Matrix operations mmult. Okay, I'll define some matrix called final matrix. Okay, and the function will return final matrix, or maybe it will be better to name it matrix product. This is really not important how you name it, it's just for the clarity. Okay, so we firstly define some matrix product, and just after that we want to define the dimensions. Okay, or we can define them here. Notice that if we know the dimensions of matrix 1 and matrix 2, we also know the matrix, the dimensions of the resulting matrix, of the matrix product. This comes from the statement that the resulting matrix always has the same number of rows as the first matrix and the same number of columns as the second matrix. Okay, so I'll call the rows as dimension m. Integer dimension m. This comes from the first matrix, which is matrix 1. And here we will use the function called, I don't know what's it called now. I think it's size. Yeah. Okay. And the number of columns of the resulting matrix, which is from the matrix 2. But notice that we cannot use the size now because we would be asking C++ to give us the number of rows, and we want columns. So we step to the first row and we ask for the size of the row, which is the number of columns. Okay, so we are asking for this now. Okay, so this works, or that should be at least working. And the matrix product will be defined as function define matrix dimension m dimension n. So this will give us an empty matrix of the desired dimensions. But so far we haven't done anything with the real matrix multiplication. So it will be the subject matter now. Well, basically the algorithm we will create now really comes from this. Okay, from this real matrix multiplication. There is nothing else you can do about that. I know that this passage of this video might be maybe a little uneasy for you, but you don't really have to understand perfectly what's going on here, but you only can use the algorithm I'll do. Okay, so I'll try to tell the algorithm, start with the row. For every row in this matrix, for the row 1, 2, and 3, do the following. Multiply for every row in this matrix, step in every column and multiply the first elements together, the second elements together, and the first elements in the first matrix and the first element in the second matrix in the second column, and so on. So this one with this one, this one with this one, exactly what we are doing here. Okay, and that will give us this matrix. Okay, so I'll start as the following. I'll start for, is always like looping when you are doing something like this. Start by defining an auxiliary integer I equals 0, I is less than dimension m, I do I++. Okay, so what this basically does is I'm telling the algorithm for every row in this matrix do the following. For integer j equals 0, j is less than dimension n, j++. So now, where we are now, I'm telling the algorithm when you step in here, you will have to loop through both of these columns, okay? Because dimension n is the number of columns we have here, okay? And when you step in the column, you do the following: m equals 0, m is less than dimension m again, m++. Or maybe, I don't know, you can really choose a different, for instance, k, so that it's not that confusing. So what this basically does is it will really do something with the specific elements, okay? I'll define some auxiliary variable called double sum elements, and here, and it must be instantiated as 0 in every loop. And here, now we step into the matrix in here and its belonging row in here, and we will do this computation, okay? So this computation actually is some elements, which is this number, okay, or this number, plus equal, which is the same as some elements plus something, okay. And the shorthand is this one, equals matrix 1. And now I really have to think about what's the elements like. Be sure it's like this, matrix 2. But I really have to think. It will be I times k times m, or k times j, okay. This will really do the computation we need. That will do the element-wise computation just like this, okay. And it will do this computation for every row in the first matrix and every column in the second matrix, okay. And it will produce some number, and we will store this number as the final number, this one, in the resulting matrix, okay, in the final matrix. So the matrix product ij equals some elements, and that's basically all. You're done. You don't really need to put any other code in here, okay, because this will fill the matrix product matrix, okay. So I'll just try to compile it. I hope there won't be any issues with the compilation. There's always something. It says it doesn't know k. Okay, so now something bad. some elements. Okay. Now it seems to be fine. Yeah, it has compiled. Okay, fine. So this is the core algorithm which will produce the matrix product. How to test it? Well, the easiest way is to follow my instructions, and we will do just the same matrix multiplication as we have in here. Okay, I have the code prepared just down here, or the inputs. Okay. And believe or not, this piece of code is the same as what you see here. Okay, because we start by 0 in C++, so basically the first row and the first column of matrix A is 0, 0 in C++. The first row and second column is 0, 1, so it's this number, it's 5. And the third column and the first row in C++ is 0, 2. Okay, so it's the number 7 here, and so on and so on. So this is matrix A, this is matrix B, and we want their product now. Okay, so these are really the same numbers as in this Excel. So we expect to receive the result like this. Okay, so we will define matrix product of this type, which is, I call this type matrix. It could be called matrix, yeah. Matrix product, and it will be MO mmult, and we multiply matrix matrix 1 and matrix 2 together. Okay, so I'll pause it in here, and surprisingly oh no, that's not what I wanted. We really get the same numbers, minus 1172, and it's ending by 31. Okay, so you really see the proof. I'm not cheating. It really went through the whole algorithm in here and calculated the matrix product. So I hope my tutorial helps you to solve many issues you have in C++, because this is really very useful, and it's very flexible and versatile, because you are using the vector, which is normally included in C++ by including the vector. Okay, so that's basically all from me, and I hope this algorithm helps you a lot, and don't forget to visit my channel again.